This is gases video number 6. By the end of this video, you should be able to solve problems using gas stoichiometry. When you do this video, you need to have your gases video number 6 worksheet, a pencil, and a calculator. Something that's recommended is your mole map from Edline. The mole map looks like this. Last semester, the only things that we had on our mole map were as follows. Let's get rid of the parts that we didn't have. You had to go from mass of A to moles of A, use the molar mass. From moles to moles, use the balance equation. And from moles to mass, you can use the molar mass as well. Now we're going to expand this. We're going to be going from volume of a gas to moles, moles to moles, and moles to the volume of a gas. To go between the volume and the number of moles, you're going to be using PivNert, which is right here, PivNert. Likewise, you can go from any other place on this map to another place. So something we've been doing lately is going from volume to moles to mass of the same compound, or mass to moles to volume of the same compound. Now we're just crossing over using the balanced equation. Example number 1. A 25 gram sample of water undergoes electrolysis. How many milliliters of oxygen gas will the student produce if the temperature is 24.2 degrees Celsius and the pressure is 748 torr? And here you've been given your balanced chemical equation. Notice hydrogen and oxygen are in grams, but water is in liters, which means that for these two problems, it would be possible to use PivNert. But you cannot use PivNert down here because this is a liquid and no PivNerts can be used on those chemicals or compounds that do not include a gas. So let's get started. On our mole map, where are we to begin with? We've been given the grams of water. So we are starting over here, grams of water. You want to find out how many milliliters of oxygen gas you're going to produce. That's a different compound, so you're going down to here. So we're going to go molar mass, moles to moles using the balanced equation, and then moles to volume using PivNert. So starting with our grams of water. 25 grams of H2. And the first step again is going from mass to moles using the molar mass from the periodic table. Now the gram unit comes down and the moles that we're going to goes on top. And these are both for H2O. So we need to write that in so it cancels out properly down the road. From the balanced chemical equation, 1 mole of water is 18.02 grams. At this point, we are now going to go mass to moles. We're going to go from moles of A to moles of B. So moles of water to moles of oxygen using the balanced equation. This is a 2 to 1 mole ratio. As before, we want our units to come down. So moles of water comes down, and moles of oxygen gas goes on top. And this is a 2 to 1 ratio. Let's see how things cancel out. The moles of water cancels out. The grams of water cancels out. And when we're done, we're going to get moles of O2. So multiply across the top, divide the bottom, and you get 0.694 moles of oxygen. Okay, next step. We have gone from mass of A, mass of water, to moles of water, to moles of oxygen. Now we're going to go from moles of oxygen to volume using PivNert. we have the following things. Our temperature is in degrees Celsius. We will convert this to Kelvin by adding 273, which gives us 297.2 Kelvin. Our pressure is in 748 torr. However, to use PivNert, I need this to be an ATM. So after dividing by 760, I get 0.984 ATMs. The volume is the unknown, and R, the gas constant, is 0.0821 liters atmospheres per mole Kelvin. PV equals nRT as our formula. We're solving for V, so we're going to divide both sides by P. Okay, so volume equals number of moles comes down, 0.694 moles. Plug in the gas constant. Plug in temperature in Kelvin. Plug in pressure in ATMs. And let's see how the units cancel. The kelvins here cancels with those kelvins. The ATMs with those ATMs. The moles with the moles. We're going to get liters as our answer. Multiply across the top, divide the bottom, and your volume is 17.2 liters to be a final answer. Okay, on this problem, a good best practice is for you to stop the video, try it on your own, and make sure you're correct. We're going to go ahead and get started. A student reacts zinc and HCl together. If 28.9 milliliters of H2 is produced at 23.6 degrees Celsius and 768 millimeters of mercury, how many grams of zinc did the student use? So in this case, we are starting out with our volume of H2. And H2 right here is a gas, so I can use PivNert for this. I'm going to solve for zinc down here, which is a solid. So no PivNert can be used down here. So I can use the PivNert here. I cannot use down the other one. I'm looking to see who's a gas. In this case, I am starting off with a volume of a gas, and I want to solve for the mass of a solid. So I'm going to start with PivNert here. PivNert. Once I get my moles, I'm going to do moles to moles with the balanced equation, moles to grams using molar mass. So starting with PivNert. Temperature is 23.6 degrees Celsius, which after you add 273 to it is 296.6 Kelvin. My pressure is 768 millimeters of mercury, which when I divide by 760 is 1.01 ATM. The volume is 28.9 milliliters, or divided by 1,000, 0.0289 liters. And the gas constant is 0.0821 liters ATM per mole Kelvin. PV equals nRT. I'm going to solve for moles, because remember on my chart, I'm going from volume to moles. So PV over RT equals N. Pressure 1.01 ATM. Volume 0.0289 liters. Write in the gas constant along with the units, and then the temperature in Kelvin. When I do this, my N, or the amount of hydrogen gas I have, is 0.001199 moles hydrogen. I am now ready to convert this into moles of zinc using the balanced chemical equation. The mole comes down of hydrogen. I want that to cancel. moles of zinc goes on the top is a 1 to 1. Then moles of zinc comes down. Mass of zinc goes on the top. This is from the balanced chemical equation of 65.41 grams per mole. Multiply across the top, divide the bottoms, 0.0784 grams zinc as my final answer.